SQL code used to create and populate the tables, SQL queries for each task, along with a brief explanation. Don't write brief explanation, you know. I already have it, so skip this part. So this part, this SQL, you could leave it as .sql file by itself. You could leave it as, keep it as txt file by itself, or you can have it within your report as part of your report. It's up to you. I prefer if you send it to me as .sql, because if I want to run one of your queries, I will ask you to send me this query. So I prefer to send it to me .txt file or .sql file, you know, whether you want to keep it in the PDF or you don't want to keep it in the PDF. The result of this, the query, like I said, this is if you provide this, you know, this will bring, you know, more, you know, credentiality, more confidence in your score, in your solution, where I can trust that your solution, this is something you have built, this is something you have practiced with. So please include the outputs from your queries. Okay, please include the outputs of your queries. Now this 100, you know, percent, I will make an announcement. You know, if you don't include the results of your query, which mean you didn't install this is what I'm assuming, you didn't install the or you didn't work with the database management system, the software itself. You solve it without it. So I will take out some points from your submission. So for example, you know, I will make it, for example, maybe up to 80. If you include the result, it will, you know, you will get 100% of the assignment. I will make an update and how's the point will be, but it shouldn't impact you if you're already started working. It is just about the submission. And you know, you don't need to include conclusions. So let me update this right now very quick. So before I forget, so you don't need to include conclusion, just forget it. I don't need challenges. And this one, you don't need it. And I just can show you this, which is again, same as that part. And as I mentioned, the screenshot. So this one, since I'm not giving you data, the result should be different. The result should be different because, for example, you know, let's say Muhammad, for example, may have a product ID. His product IDs start from 10, 20, 30, 40. Maybe who else? For example, Savas could have, for example, product ID 1, 2, 3, 4, 5, 6, 7. Somebody else have customer ID like, you know, 150 or 100, 230, 300, 400, so on and so on. So, and the same for first name, I'm not expecting similar data sets. If you are working in a group, again, let me know about this group. If you didn't share it before, you still have time to report the group. And this assignment, like I said, it's due in 2 days. I can extend it. I don't know if you guys win or if you have already started, but I can extend this till when? Friday, for example. Let's keep it Friday.
Professor?
Yes.
Sir, I
Ali?
have like few questions. Like, my Windows
Yes.
was not allowing me to install like the SQL. There was like a Windows corruption error. So I used an online platform to like run my
Fine.
queries. Is it fine?
Fine. I was about to say this. When you start talking, I said, okay, I missed talking about online tools. Yeah.
Okay.
Yeah.
And sir, second thing is that
No,
we can't
what's that?
upload like SQL file.
What? You can?
We the platform, the Canvas is not allowing us to like upload the .sql file.
Oh, yeah,
It
yeah.
says unsupported document.
Yes, yes, yes. But before I forget, whatever you use online, I mean, please share it with the rest of the team so they can benefit from this as well. And they don't need, for example, if they don't want to install, so they can install, they can use the online tool that you work with. So yeah, and thank you, Ali, for bringing this. So what is the tool? So I have right now I enabled SQL. You can see.
Okay.
What is the website that you're using?
Just give me a second.
Put it in the chat. Maybe put it in the chat
Sure, sure,
with the link or the URL so they can
sure,
benefit from this.
sure. So, thank you.
Okay. Okay, so final notice here again, the grading rubric is 100, yes, but like I said, see this note, I just added this in front of you. To get full mark, you need to share the results of your query so I can know, what you are doing, how is your query working, not working. But keep in mind, every single bullet point is a question. I'm giving you the titles here. The titles here is to guide you and give you hint what you need to do. For example, this different joint types. This means you need to use the lift joint. So you have to go to this joint section in that website and learn about it if you didn't do before. If you didn't read about the joint before. Same for data cleaning. I'm asking, this is data cleaning. See, we are removing. So this is data cleaning. Okay, so every single bullet point here, is in all four parts are, sorry, every single point is a query, and that you need to develop. Okay, so I will stop here. Just I wanted to remind you about this because it's good assignment. You will learn about SQL, and I will move forward to the um, another interesting topic in analyzing data. If you don't have any questions, let's give one more minute for questions. Any question
I have question. Uh,
about the assignment?
yes,
Let me
it is.
open it.
Uh-huh.
Okay, what?
While I inserted sample data to the tables, customer table, products tables, also orders table, I need to add the condition in the task. For example, part 1 and 2, filtering and sorting. It says the write a query after the date 2023.
Yes.
Yeah, so I need to in the orders table, I need to add those dates in the like inserted, populated to the table. Uh,
Okay.
Also
Yeah.
another one, like part
Yeah.
4, handling null values in city. So I go
Where
back
is it?
often time to
Yeah.
add those conditions to the tables. Some of them I know my query is correct, but I don't get result because the condition is not applied to my data. What do you suggest for this? So
Actually, I suggest that you revealed one of the secrets for this assignment. So I recommend all the time, read the whole assignment before you start working on it. I mean, you already gave. I mean, you you are driving me to give the hint. So, but the point here is, see this date. You need to make sure, since I'm giving you this, your result will get your query. So okay. So before I continue, I will give you 5 points, as or 10 points in this assignment as bonus because you already, I mean, gave hint to the student, and I cannot run away from not answering your question. Okay, so since the query here is asking you write a query to find all orders placed after this date. Okay, so if you go back to the orders table, you have order date. Now, if you don't have any order date that's after January 1st, 2023, then your query will return nothing. For me, I cannot validate, right? So I need to see then for me to, the way for me to validate is I need to go back and check your data and see, check the records one by one. If you have 10 records, I have to go over them one by one and check if the orders table has this date or no. But I mean, as for the sake of the assignment, if you want to do a complete job in working in this assignment, include, some dates, some orders before 20 January 1st, 2023, and after January 1st, 2023. In this case, if I take a look to your code when I'm grading, for example, I see, oh, okay, let's say, Sedaf has, let's say, 10 records in orders table. I see 3 of them in the results. Oh, that's fine. So her query is capturing, so the filter in her query is filtering out some records and keeping out some records. So that's how you want to build this the answer. That's how you give more how you make your answer complete. The same for this, for example, the price is between 50 and 200. Means inclusive, means, they have to be 50 greater than or equal, less than or equal 200. When it comes to the prices in the products, where's the product? So you have price. So you have to make sure you have prices, below 50, between 50 and 200, and more than 200. So in this case, you are capturing some of them. So be careful, study the records that you want to insert here before you work in the assignment. You need to make sure every single query has an output. You need to make sure every single query has an output. For example, find all customers where city is null. Null means nothing. It should be empty. So when you fill the customers here, where is this? Here. When you fill records, so have some customers with city, have some customers without city. And your query should bring at least one record that has city equal null. So yeah, Sadaf, gave you the hint for this. But
Okay,
remind me, send me team message, Sadaf, after the class. Remind me about this, and I will give you bonus 10 points for this question.
okay, thank you so much.
Okay, so let's move on then to the material. So in module in module 4. So module 3 is about the project. Later we'll have phase 2. I will add phase 2 to the project here. Be careful about the project. Let me spend 4 minutes, then I think the rest of the class, the material is going to be for the slides. I think there might be enough. Some links I was planning to go over them. I think I have duplicate files. The same file, duplicate, shouldn't it impact the file? Let me see. Can I click? Oops. I broke it. Let me see if I can edit. Find the file. Where is it? Oh. Okay, let me find the file where it is. I think I lost it by deleting that link. I will fix it, right after the class. I have another class right after the other class. I will fix it. Okay, so the other assignment is about the project, and when I say no coding question, please don't submit a code to this. I will not grade it. Okay, no coding questions. So this one, it's not coding question. It's not coding question. Read the data carefully and identify any mathematical relationship between these fields. Here, show how did you get the answer by writing code. So EF code, EF code, EF code, and 4 is code. The numbering is broken. How this is happening? Okay, this should be 5. So 4, 5, 6 are coding questions. And I will give you the data set. So let me save it. 4, 5, 6 coding questions. This one, read this one. I don't know if you guys have started this or no, but read read the data, read what's included in these tables, in these fields. These are column names or fields in this data set. Read them. Try to understand what is the relationship. Is there any relationship? What does it mean, relationship? For example, a relationship could be, I'm just giving you, could be total cases, this one, total cases equal, for example, maybe total deaths plus total tests. So the relationship, it doesn't mean that you need to include all the fields. See, I'm saying here, among any of the following fields. So there could be active cases, for example, as a relationship equal, for example, total cases minus serious, critical. So you need to find the relationship between these tables. There is a relationship between, one of them, one of these fields equal, an equation of the rest, of some of the rest. So it is simply just take a look to the table. And the idea of this, the idea is not to reveal the relationship. The idea is I want to show you, sometimes you get data that has numerical fields, and you might find nobody who can answer you what is the relationship between these fields. They are numerical fields. If you are building, let's say, a linear regression model, you will face a problem, where for example, linear regression does not like that two fields have a strong relationship with each other. We call them collinear. So they do not like, sorry, linear regression does not like collinearity, which is the where two fields, they behave the same. If one of them is increasing, the other one is increasing. One is increasing, the other one is decreasing, for example. These two types of relationship. So how I can discover if there is no linear relationship, sorry, there is no high correlation between these two fields. There is multiple ways. Either you can use the correlation plots, and get the correlation score. If they are very close to each other, you can drop one of them. Or I can do, manual inspection. I can check by my eye and take a look to these data, to these fields, and try to identify if there is a relationship. So that's the reason of this exercise, just to expose you to one of the practices, in looking at the field. Nothing, I mean, code is not everything. So you need sometimes to open the data set, look at the data, read the data, try to understand the fields by yourself, and try to find some relationship between them. So after you find the relationship, I'm asking you to prove that it does exist using a code. How you do it? For example, if you find out a relationship that, let's say, which is, as an example, total cases equal total deaths, let's say, minus total tests multiplied by active cases, for example. You need to give me this relationship. You could write it in a piece of paper and take a picture and include it in your file if it's easier for you. And then you need to write code to show me, okay, that the result of the equation equal, for example, total cases, right? Because I said total cases equal the expression in the right side of the equation. So you need to show me, for example, total cases number, the values in total cases, and show me the result of the equation that you came up with. Okay? Or for example, your equation could be, for example, total tests. So total test could be, for example, tests, this one, minus deaths minus serious, for example. What you need to show me in one column in your code, so your code should print two columns, should print the left side of the assignment, which is total test, and the result of the equation that I just mentioned in another column, to show me that what you have came up with is actually true. Okay, is actually true. You may discover two relationships here. I need only one. If you find two, you want to include them, it's up to you, but I need at least, one relationship between this. So again, 1, 2, 3, no code. If there is code solution, I will not accept it. If there is, for these ones, 4, 5, 6, the solution should be only code, except part 4 should be part of it, handwritten or whatever, and then the other part is code. I'm asking you which country has the maximum number of test cases. This is code. This is code. Develop at least 3 different scatter plots and show 3 different pairwise relationship. When you develop this solution, remember in the first class, we said when you provide a plot, you should provide at least one sentence that describe a fact that you are seeing in the plot. Okay, so these, I'm asking you here, 3 scatter plots that show 3 different pairwise relationship. So 3 scatter plots means you need to find plot x and y and show me some relationship there and describe that relationship. Okay, so you have to provide description. I'm asking you explicitly to provide description, but if you go back to course policies, you will find that plots will get 50% only if there is no description. Okay, so that's part of this is phase 1 of the project. Any questions? Okay, so
Can we extend due date of this too?
what
Extend the due date, please.
what is the due date? It's
I mean,
it's what?
23rd. We are working on SQL also. So
You are
if you
supposed to work since 10 days, so I will take out the 10 points. Okay, I will make it Monday. Sounds good?
okay.
Okay. Okay, one more day. Um, okay, so these are the assignments. Now, one last notice. When I sent an email about the students who provided AI answers, I didn't ask the student who didn't provide AI answers to submit again. So I'm not grading you. If I didn't give you a comment in my grading that you have AI answer, I'm not going to grade you. I'm only grading or regrading the students who I left a comment for them that your answer has AI written text. So, and those only the group that I will be regrading. Because I got checked today, I wanted to regret that part. I checked why the class, most of it are submitting. And then I figure out that, everybody is submitting again. But yeah, um, because of Ramadan, I have low performance in grading, honestly, but I'll try to do my best the upcoming days. Final thing here before we move to the new material. I rescheduled the Monday of 31st because I got a question from one of the students that could be Eid and they want, to be with their families. So I moved it to the next day. It will be Tuesday, just in case we are on the safe side. Okay. So now let's talk about what we have today. So Um, in today's session, I want to talk about categorical data analysis. What does it mean, categorical data analysis? Categorical data analysis is about, excuse me, is about, analyzing the data that has the features that has categorical uh, values, which means they are not numerical values. They are, like, gender, like, eye color, for example, these kind of data. For this, usually, and it's important to have it, as part of your analysis. When you have a data set, you have a mix. I don't want you to, to believe all the time, okay, I have data set, I only need to build plots for numerical fields. What about the categorical fields? The categorical fields should be represented, fully represented in your, what is it? In your plots. And the plots actually has, has a name, as we call it at the beginning of the class. We call it explanatory data analysis, EDA. It's one of the phases in every single project. Actually, what I'm asking you in the project phase one, if you think about it, I'm asking you to do kind of a format of an EDA. Okay, if you take a look to it, you think about it, I'm asking to do EDA. What we do in the EDA, we try to understand the data, we try to print what is the minimum, the maximum, print some, scatter plots to see if there is relationship. We try to summarize or provide some description for these plots um, to show if there is a fact that worth to be communicated with whoever reading or looking at these plots. So now, I will start with one categorical field. So sometimes, I want to talk about, suppose you have, let's say, city is a categorical field. Gender is another categorical field. Hair color is another categorical field. There is a concept, or a terminology called bogus values. What is bogus values? So bogus values, let's, read this example. If you have a data set that has one of the following fields, for example, what kind of check, you would do? So suppose you have the blood type as, acceptable blood types, like, for example, O plus, O negative, and so on. If a blood type is in accepted blood types, fine. We know it's accepted. Uh, One second, please. If the blood type, like, if you have C plus, is it accepted blood type, for example? No. O minus minus? No. it's not accepted blood type. So 1 second, please give me 1 second. Okay, so you know, after having these different listing the acceptable blood types, will help us capture the blood types that are not accepted. So for example, if you have a data set, it's good. So what you need to do, what you need, for example, if that data set has a column called blood type, and what you need to do to check that there is no weird values in this data set, that does not belong to a blood type. So something like, O negative negative or C plus, for example. What you need to do, simple thing, you need to print the unique or distinct values in the blood type field. So when you print the unique or distinct excuse me. So if you print the unique or distinct blood type values in the blood type field, you will be able to tell, oh, I see C plus, it's not a blood type. I see O minus minus, it's not a blood type. Okay, so that's kind of, uh, identifying, weird values or strange values that does not belong to um, 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 that does not belong to that field values. Similar for letter grades. C plus here is not accepted, right, as a blood type, but it's accepted if the field called letter grades, right? So this is telling us that the bogus values, looks like they are what? They are inaccurate. They could be inaccurate. They could be incorrect values. They could be inaccurate or could be incorrect values. Now, why I'm saying incorrect? Why I'm saying inaccurate? Because maybe the person who did the data entry, by mistake added O minus minus, where the intention is just to make it O minus, right? So this is make it inaccurate. In terms of incorrect, blood type, for example, if there is no way in the earth that somebody could have C plus, so this is, becomes incorrect value. So in this case, because it has a different value that's not even close to what we know as a blood types, so C plus becomes incorrect. O minus minus, since it's very close, maybe a typo, looks like a typo here, so we call it, inaccurate. There is no strict definition for inaccurate or incorrect, but you better judge, whatever the values you are talking about. So again, bogus values is kind of, again, inaccurate or incorrect values in the data field, in the categorical field. Again, keep in mind, blood type and letter grade both are categorical fields. Okay, they don't accept numerical values. They accept only string values. Uh, Inconsistent categories handling, so it could happen. Sometimes, if you take a look, to the data, you might find values like USA, for country. Suppose you have country field. You might find values like USA, USB, US, United States with S small, United States with S capital. This is called inconsistency, and this impact, your work. Today, for example, where I work, we had a presentation, we have a data science presenting about, XGBoost is one of the machine learning models. And, we noticed that this, that this data scientist has a problem in inconsistency problem, where they are using the name for, we have a product called VPN. So he's or she is keeping the values in that column for the product name as VPN and virtual private network. So she kept both. For XGBoost as a machine learning model, XGBoost likes the categories. So XGBoost will think that VPN is different from virtual private network, and will treat them differently and will build different trees for them. And this is how XGBoosts work. But this is inaccurate. Why? Because both are similar product, same product. So, and gave her, wrong results. So capturing this, she had to go back again and, combine, VPN and and virtual private network, make them same name. Either convert all of them to be VPN or convert all of them to be virtual private network. Consistency is very, very, very important in later stages of data analysis. Maybe at the beginning you could, skip fixing, you can say, okay, I'm gonna keep it USA and I'm gonna keep US. That's fine. No, not fine. It's at the beginning, it's not fine, especially if you have histogram, for example. Think about it. The histogram will show how many records you have from US, how many from USA, how many from United States, but all of them the same. So you are misguiding your audience. Same for blood type. Suppose you have these values in the data set in that field. See, it's the same. So you have to make sure you have consistent, values for your categorical fields. How we check the consistency? Again, I print all the unique or distinct values for that categorical field. These unique values will tell me if there is bogus values and will tell me if there is inconsistency. How the inconsistency or the bogus value could happen? Typo. We saw this. Typo. O minus minus. How it could happen, if it's a free text field. In the user interface where people insert the data, they might, if I give them a free text field, which means, for example, like when you fill an application that says, first name. First name, you just type, your first name. It's called free text field. I can't type whatever. But actually the solution sometimes, if you are, if you want to maintain the consistency in the user interface or in any form, give them a drop down list. Let them check, let them select, for example, the country, USA. Like this is why, for example, if you take a look right now, I mean, in many applications in the internet, all the time, country, you select it, state, you select it. They are not giving you this option. Why? Because if it's a free text field, people will mess with it. They will fill USA, they will fill US, they will fill United States, small letter, capital letter, and so on. How to check? Again, unique, and then it's better if you sort them. If you sort them, so after you get the unique values, sort them in alphabetical order, and you will be able to, you will be easily you will be able to figure out, if you have inconsistency or if you have bogus values. And this is in Python. Simply, sometimes you just print. This is the field data frame, field name, and just unique. Will give you the unique values. Okay. Remapped categories. Remapped categories. Sometimes, if you have this is kind of or type of categorical fields. We call it remapped categories. So the income field in any data set will be, we are expecting that to be numerical, right? So for example, income is 30K, 50K, 60K, 100K, 200K per year, for example. So sometimes, we convert this, we want to deal with income. There are some situations um, in machine learning models or in the explanatory data analysis. Sometimes it's more readable if you show the distribution of your income, for example, as histogram, or it's better if you can create categories like this: 40K to 70K, 75K, and 75K to 100K, and 100K 120K, 25K, and so on. So we call this remapped categories. So sometimes it's advisable, like I said, to create remapped categories. You can search about it, and read more about it, but this is what does it mean. And the same, for example, age. Sometimes it's good, to have, to deal with age as categorical field. Again, keep in mind, these are numerical fields, but I want to deal with them in my plots, in my visualization, in my analysis as categorical fields. How I do that? I map them. I map them to ranges. These ranges is what, it's something I decide. How I decide? This is a big question. How to decide these ranges? It depends. Now, we are talking, for example, suppose I'm working, it depends on the situation. For example, if I'm working with, university data, you guys are a student, you are master students, and the same university has bachelor students. I'm expecting, the minimum age in the university to be 18. The student, could stay in their bachelor degree, for example, maybe up to 6 years. So 6 years will be 24. So what I could do, for example, I could have a range that says, okay, 18 to 24. This is the range for the students in the bachelor degree, for example. Then from 24, sorry, then another range that between, for example, maybe 22 to uh, to the, maybe 50, which is the range for the master students. And then I could have another range that could include, some older employees, some younger employees. So these ranges, it depends on what you are looking for. But my point here from this example is there is no need in this situation, if I'm working with the university data, to have a range that says, for example, 10 to 18 or to 17. Why? Because nobody either work or study in the university if they are 17 or below. I mean, what 70 is not the cut, but if it's acceptable, maybe in some college, yeah, community college, that's okay. But I'm just saying, we are not expecting younger than 17 or 18 to work or study in the university. So this range shouldn't be part of my data. Okay, shouldn't be part of my data. If I'm working, for example, if I have data that's coming from Texas Children, the name says, as the name states, it's Texas Children. So this hospital only for children up to certain age. So the age group should be, for example, less than 1 year, between 1 year, for example, to 3 years, something like this, 4 years or 5 years to, for example, I don't know, maybe 10 years, and then 10 years to 13 to 14. So see, these are the ages. These are the ranges, but not something, that says, 40 to 50. It's Texas Children. It's every single data over there. It's about children. So that's how you decide, Um, there could be other ways to decide, but I'm just bringing you or giving you some examples. Visualizing categorical fields, there's plenty of options. You have box plots, you have count plots, and you can see, for example, the histogram is one of them. Um, uh, uh, this is a histogram of parents, for example. You can see how many parents in this age between 64, 65. This is how many parents we have. Sometimes, if these numbers are big, these are small numbers, but if the numbers are big, sometimes it's good to scale the fields. So if you are providing or visualizing the scale of parent ages, for example, histogram, if the big numbers are big, for example, like something like the population, salaries, it's good if you scale them. Okay, scaling them will maintain the shape. It will not change it, but at least make it the range here, make it more readable. Okay, because if you have, suppose, a population of a certain country, or a particular country could be, for example, 75 million. So we don't need to read 75 million as a number here. It become confusing to read. It's advisable to, scale the numbers. If you have two categorical fields, so we spoke about how to show, some data or some findings about one categorical field. Suppose we want to show, as we did in the scatter plot. Scatter plot show the relationship between two numerical fields, but we want to do the same here. We want to show the relationship between two categorical fields. What you can do is you can print what's called total table or matrix. Some programming languages, they call it table. Some of them, they call it matrix. Matrix, you can have, for example, the count of exposure and disease. So you can say this is a field name, this is a field name. And you can say, for example, who have exposure to smoking and they have lung cancer. We have none, 9 of them. So they have yes and yes, 9. Who have exposure to smoking people? No. And they don't have disease, it's 47. Something like this here, for example, who have exposure and they don't have lung cancer, we have 31. So this is showing us relationship. We have, for example, 47 of them. They don't smoke and they don't have lung cancer. We have 31 who smoke or who are close to smokers, let's say smoke or close to smokers, but they don't have lung cancer, 31. These are good results, if you are smoking. So yeah, these kind of, matrix, matrix or table is kind of a way to show the relationship between two categorical fields. Okay, now uh, there is other thing can be done with two categorical fields. Uh, this resource, this is part of the resources that I left at in the last slide, which is for you to read about the test of association. The test, what are the tests of association, and this will give you some tutorial about or a tutorial about how to test the association between categorical fields. In this visualization as well, you can see we are presenting, different informations. You can see here, we're talking about coffee. So the x-axis is about coffee. So 5 plus cups, less than 5, you can see two groups. We have coffee, two groups. Less than 5, we have 5 plus cups. And this is divided by what? By the smokers. If you are a former smoker, you smoke between 1 to 4 cigarettes per day, 35 to 44 cigarettes per day, and 35 plus cigarettes per day. So see, one categorical field, second categorical field, you can see, and the third categorical field is this one. I forget what is it actually, MI and then non-MI. So, but we have what's called MI feature. So 3 categorical fields, we are showing the relationship between 3 categorical fields. Imagine. So coffee is one of them. The second one again is about smoking. The third one is about MI. So this is kind of a plot where you can show the relationship between 2 or more categorical fields. So here I'm just describing, what could be later in the project. You can read it by yourself. I want to go to these plots and I want to show you that these plots are really good ones. This one is about visualizing a categorical field, a variable. This is from University of Iowa. This is coming with a data set. You can play with the data set. This is an R. This code is an R. But here is showing you, for example, see bar chart for frequencies, basic one. This is, you can see this categorical field here, showing you the count for each hair color. See, they are telling you here. Sometimes, okay, you see it. If you want to compare black with blonde, sometimes if they are close to each other, they are not readable. This is not very good. But blot, to make it more readable, is good to sort them. So I can know, I didn't need, to sort by my eyes here. I can just read it from left to right, sorted. So they're showing you how to sort them. Um, um, adding grouping variable, for example, you can see the same, we're talking about, hair and eye color. See, 2 categorical variables. This is called facet wrap. When you divide them, you can see these are 2 plots next to each other. The difference between this and this is that, see this ligand, you don't need to have ligands next to each other. You can break them down by, you have one ligand and you can have it in, next to each other. This is facet wrap. You can have pie chart. See, they're giving you ideas with solutions. This is a very good one. I like it when I was researching, so I like to share it with you guys. This is called waffle chart. This is one of the good ones. Um, you don't need to be crazy about them. What the takeaway, if I am a student, I would summarize, for example, in the side, or which one I like, why I'm using them. It's not just to show more colors. It's not about to show, different, plots for sake of showing. It's important to see, why I'm using this one, why not this one, is to answer this question or that question, or to deliver this, or to provide this fact versus the other fact, and so on. So this is one link. The other link is this. This is another link. Same logic, but this is a different data set. They're showing you, this is another way to show the count. Let's make it more readable sometimes when you have long, lengthy names, field names. So it's sometimes good to keep them in, in this way to round it 90 degrees. So this is very simple one, but there is also you can read more about the, see this is, visualizing numerical distributions, but since our class today is about categorical, you can benefit from it to see about others. And the last one is this one from Seaborn Library. You see, this one is really good one as well. Sometimes you need these ones. See, Books of Bloods, my favorite. Violin one. It teach you how to read them. It teach you how to come up with conclusion. So you can see, the difference between these and these. Different plots, different options for you. I highly recommend, using this. I highly recommend, if I can see some of them in the answer for part 6 of the project phase 1. Yeah, so that's all about the test of association. This link inside the slides, and you can see it here. There is also, you can read about encoding categorical variables. Encoding means, when some machine learning models does not like the categorical variables as they are. They don't like, for example, to see the hair as black and red or blonde or whatever. They like to see them as numerical data. So how we convert categorical data to, or categorical field, to make it a numerical field? We use what's called encoding. So if you search about encoding categorical data, you will find articles in the internet how to encode them. In Python, for example, there is a command called get dummies. Get dummies will make the encoding for you. Okay, so it's worth to read about it and see how it works. Yeah. So yeah, I tried, to highlight, the main topics, guide you in your reading, in your self-reading. And yeah, that's all about today. I just want to bring some attention to categorical data analysis, how it's important to find out bogus values, how it's important to check the consistency, how it's important, to know that categorical values, fields could come from numerical fields. Not only by their nature, they should be categorical all time. So they could be a remapping or mapping a numerical field to categories. These categories you decide based on the data set you have. We spoke about, showing different relationships, and these links will give you more context, better than my slides as well. So, but I try to use them as guideline for you. Sounds good? I have to jump to another class. If you have any questions, please post it in the chat. Otherwise, have a good evening and talk to you in April 1st. Bye-bye.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.